Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 4 of the lesson on partial fractions, and in this video I'll be looking at what to do when the power on the numerator is the same or greater than the power on the denominator. Okay, so here we have an example: split 3x squared minus 3x minus 2 over x minus 1, x minus 2 into partial fractions. And you might look at that and think, okay, that's two linear terms, so I'm going to write a over x minus 1 plus b over x minus 2. And if you did that, it wouldn't work. And the reason it wouldn't work is if you think about what we're going to do as the process, you would be cross-multiplying. So you'd have a times by x minus 2, so you'd have ax, and then over here you'd have b times x. Where's your x squared term coming from? So what have we got to do? Well, we've actually got to break it up first before we can do partial fractions using algebraic long division. How do I know to do that? Well, how you know to do that is that if you were to multiply out the denominator, which would be x squared minus 3x plus 2, you can see that the highest power on the numerator is the same as the highest power on the denominator. And what that means is it doesn't split straight into fractions. You have a whole number part and then you have some fractions. Sometimes you're given a bit of a nudge. You're told to put it into the form a plus b over x minus 1 plus c over x minus 2. But you're not always given that nudge, so whenever you're doing partial fractions, always check the highest power on the numerator and the highest power on the denominator. And if the power on the numerator is the same or greater than the power on the denominator, then you need to divide first. So let's do that. I've already expanded this out, so let's put x squared minus 3x plus 2 on the outside of my division bus stop, 3x squared minus 3x minus 2 on the inside, and do algebraic division as we would usually do. So x squared into 3x squared goes 3, multiplied back by the divisor, 3x squared minus 9x plus 6. Draw in the line and subtract to find the remainder. Negative 3x take away negative 9x, positive 6x, and then negative 2 take away 6 is negative 8. Well, what does that mean? What that means is we've written the original expression 3x squared minus 3x minus 2 over x minus 1, x minus 2 as 3, the quotient, which is the whole number part, plus the remainder, which is 6x minus 8, over x minus 1, x minus 2, which is the divisor. It's a little bit like saying if you had 22 over 7 and divided 22 by 7, you'd get 3, which is the whole number part, remainder 1, so you'd write 1/7. It's a little bit like that. So whole number part, remainder, divisor. And now what we're going to do is we're going to split this bit into partial fractions. So pretty skilled at this by now, so I'll do it at a reasonable pace. So 6x minus 8 over x minus 1, x minus 2 is going to be the same as b over x minus 1 plus c over x minus 2. And you'll notice that I'm using b and c, not a and b. That's because this is the form that I'm looking to express my answer in. And as you can probably see, the value of a that I've already found is 3. That was the whole number part. Okay. So I'm going to skip a little bit here. I'm going to say that 6x minus 8, which is the numerator, would be equal to b lots of x minus 2 plus c lots of x minus 1. Now obviously in reality it's all over x minus 1, x minus 2, but we end up comparing those numerators anyway. Okay. Which values of x are we going to substitute in? Well, the first one we're going to use is x equals 2, because that makes this bracket 0. So if x equals 2 goes in here, I get 6 lots of 2 minus 8 equals b lots of 0 plus c lots of 1. Just for space, I'm going to go over here. So we have 4 equals c. So c equals 4. Let's just box that. Okay, we've used x is 2 to make this bracket 0. We're now going to use x is 1 to make this bracket 0. So if x is 1, I substitute in 6 lots of 1 minus 8 is going to equal b lots of negative 1, because it's 1 take 2, plus c, which is going to 0. Okay, I'll do the next bit here again. 6 take 8 negative 2. Just be careful because I'm going to have negative b there, which means that b is 2. And therefore my final solution. So I started with 3x squared minus 3x minus 2 over x minus 1, x minus 2. And I have shown that that is exactly the same as 3, not forgetting this whole number part we found out through algebraic long division, plus b over x minus 1, so 2 over x minus 1, plus c over x minus 2. So there we are. This expression here expressed in partial fractions, and we have a whole number part because the greatest power on the numerator was the same as the greatest power on the denominator. Job done.